Okay, let me show what we were building from past few days. Let's open the terminal. Let's cargo run play as dash ghost.gif. It renders a GIF, of course. What else do we have? We have few of the sub commands like frame. This prints the frame of the GIF. This is our GIF frame. And also we can print the metadata. So let's name this as inspect. So these are the few commands we have already made for our CLI. The inspect returns the canvas dimensions, frame count, and what kind of repeat, and also total duration of the frames. Hey everyone, I am Akash. I have been learning Rust for past few months. I thought of an idea to build a GIF to ASCII renderer in the terminal. I have done some research and there is no existing open source Rust CLI. So I think finding such projects in this vibe coding era is already pretty rare. So the tutorial will be very slow paced. It's for beginner. They will be using few of the libraries and keep it very simple. This is for the people who are building their first project in Rust. Like they know the basics, declaring the variables, borrowing ownership. Let's just get started with it. I will give a overview of the project, like what is the architecture and all. So let's get started. Let me first show you what an ASCII image looks like. Let's search for some ASCII. Yeah, so these are the ASCII drawings. So we will be like converting the GIFs into such drawings, just like how video is frames of images. We will be rendering the frame of ASCII characters to create a video-like effect. So that's the overview. Let's get started with the architecture. In the terminal, we will be rendering our GIFs and the few of the libraries which will be using. These are the few libraries we will be using. Anyhow, for error handling, image for pixel sizing, Crossterm for handling the terminal to wipe the image. And so this will be the pipeline. So the very first thing we will do, we will be using a clap library to create our CLI, GIF module to decode the GIF to extract the frames from the GIFs basically, and resizing and brightness is the core idea. Bright pixel, then it will be represented by asterisk. I mean, at the rate a dim area, then it will be represented by a dot. Let me show you an example. For example, let's take this rotating galaxy. Sorry, my bad. As you can see, the brightness is adjusted using the ASCII symbols. I hope you get the idea what I mean. So we will be creating something like this, which will be rendered in the terminal. We will create a rendering module, which will put the frames into the terminal and the loop basically to create the animation effect. For terminal management, we will be using Crossterm. I mean, that's what I have in mind. It should be pretty easy using the libraries and all. If you still haven't got an idea, while writing the code, I will give you answer in depth. So hang on till then. All right, so let's get started with the code. I am using NeoVim. You can use any code editor you want, whether it be VS Code or Helix or whatever you use. Let's create the directory and head into that directory, naming it as Glyphix and cd Glyphix. And now we create cargo connection. Let's open it in NeoVim. Okay, so these are the four libraries we will be using. Let's install them. Forgot to turn on the caster. Let me turn on the caster. Okay, so you can see it on the left bottom. All right. So let us first open the terminal. Let's add the dependencies. Cargo, add image, GIF. Then what else do we have? Anyhow, let's install them. Also, let's also install cargo, add its clap. We need its feature derive. Okay, it's called features, my bad. It is called features. So the features flag just allow us to use derive macro on that library. Let's check if the dependencies are installed. Okay, we have anyhow clap GIF. This feature flag enabled this derive. Now let's create the files for the CDSR. Let's head inside and then touch ASCII.rs. Then we have terminal.rs, GIF Decoder .rs, CLI.rs. Close the terminal. Let's head back in. Let's head back to the main and let's use for the result. So it would return and result, which is coming from the anyhow module. So let's see hello world from Glyphix. If our setup is done correctly or not. Let's save it. Okay, it expects a result. Let's give him the result. Let's just save this file. Let's open the terminal. Cargo. First, let's cd out. Let's do a cargo check. Okay, let's do a cargo run. Now it's compiling. I hope we don't have any errors because we have not done anything yet. Okay, hello world from Glyphix. Okay, it's working as expected. CRUD format of our application. So now we will be giving command as Glyphix play, let's say demo.gif. Okay, let's have it here. So here is our main command. Gfix is our main command. Play would be play is the sub command. Demo gif is the argument we will be giving. That is the path. So now the argument we will be passing will be the path to the gif. Now in some case it could be like assets slash demo.gif, but in other OS it may be as asset slash but other slash demo.gif. To tackle this problem of which slash the OS uses, we will be using something called pathbuff CLI. Okay, so let's head to that, and now we will use standard library pathbuff. Now using that pathbuff, we won't have to deal with the issue of this forward slash or backslash. It would be handled by the pathbuff. Let's derive debug from a parser. Also, like we need to import that parser as well. So use clap. We need parser from clap sub command. Let's find. We'll use the attribute command, and here we will pass the metadata of our CLI, which will be name. The name would be Glyphix, comma enter version. Now we can pass the version manually, and if we left empty, it will fetch the version from the cargo.toml himself. Let's give it about. It gives the small description of what our app CLI does. Converts GIF into ASCII animation in the terminal. create the pub struct CLI. This will be the entry point for our CLI. Uh, it let's have command subcommand. This attribute makes sure that it knows we will be giving him subcommands. Command. Now the user gives whichever input, it will be stored in this struct. Let's derive debug first. Derive debug subcommand. Now this enums will tell the CLI what command options do we have here. The very first would be play, which will followed by GIF path, which will be the type of path buff. Head over to main to test it as well. Now we need to import the CLI module as well. Let's get to the top 0 mod CLI. Let's use create CLI. And from CLI, we will be using our CLI and command enum. Let's declare the variable it's as well. Let's declare the CLI equal to CLI parse. So this parse function comes from the clap. So we need to import clap as well. Use clap parser, I guess. Parser, head to this. We don't need this now. We need to match the command CLI dot command. We will fetch that so from the command enum, which will be play, and it will be the GIF path. So when we find this, let's just print that, print ln the path to GIF. Let's use GIF to path dot display function. Let's save it. Let's test if we blundered something or not. Let's run cargo check. Uh, cargo the cargo run and then hyphen play assets. Okay, we need to create our assets folder as well. So let's exit this first. Let's add a file here. Assets, creating asset folder, and file GIF download. And let's use this website. We will try to find some simple GIF which we can recognize. This looks fine. This has much more movement. Let's go for this. Let's close this. Let's download it for. We are just exporting the downloaded GIF to our assets folder. Let's head back to our terminal. Now it should has that asset. Yep, it has asset, but it has complicated name. Let's just rename it to something simpler. Ghost.gif sounds right to me. I think that's good enough. Now let's try cargo run. It's compiling and it gives the path right as we want. So yeah, it's working pretty fine. Also, I would like to show what the slab helps us with. We can also do cargo run slash help command. Shows us the command we have, play command and help command. Now you might be thinking like we haven't declared any help command. So the clap rate gives this help command pre-built and also the version command. We can also do cargo run dash dash slash version. It will shows the Glyphix version. So these are provided by the clap crate. Let's close the terminal first. Let's head to, by the time, let's also check the Git's GIF package. This is the crate IO. Let's go to the documentation. In this GIF encoding and decoding library, we will be using the decode option, color output, disposal method, the repeat enum. If you want to read about it much more, you can explore the docs and all. Let's head to the terminal. First, for reading the GIF file, we will need this associated function, sgd path. Now you might be wondering why we are using path here and path buffer in the CLI.rs. The path buffer mutable string, whereas this path gives us the only reference. The GIF decoder only needs the reference, so we are using path here. I will use anyhow the bail function. What is bail? It's an early exit kind of question mark operator. Bail, then context, and finally the result. To return the result, use GIF. What do we need in GIF? Color output, then decode options, decode options, then disposal methods, and finally repeat. These are associated functions we will be using. Structure, derive, debug. So pub struct GIF metadata. We will have this. We will be also having pub struct frame metadata. To be quick, I will be just copy pasting the metadata we are having, which I already have here. Let me just copy this. Pub canvas width, which will be unsigned integer u16. Okay, pub frame count. It will be of u size. Pub repeat. We have pub in milliseconds, so I'm not mentioning that here. Of vector frame metadata. So I realize I have now it will be having pub index. It will be of u size. The dimensions will be of 16, so width will be 216. And let me just copy paste this three times. Would be left. Let me just make it sure it's clear. For example, this is our terminal. The distance From here to here, this is what we will call left. From here to here, what we call the top. And this is the width and this will be the height. Then we have the delays in the animation. Delay CS U16. Delay mess U16. Let it be U64. Yeah, you might be wondering like why do we need to have centiseconds? By the way, centiseconds is one divided by 100 second. The GIF rate itself decodes the information in centiseconds, and then we will convert it into milliseconds. Disposal. Okay, so disposal will be of disposal methods imported from the GIF crate. Then we have pub transparency, which will be okay, it has transparency, which will be of type boolean, and also pub interlaced. It would be a boolean as well. So disposal methods gives us the idea how to clear the terminal and redraw it. Interlaced is whether it affects the decoding or not. The frames are in interdependent. Pub function inspect GIF path as an input. It will be of type and path, and it will give a result GIF metadata. Let file equal to file. It's file open. The path we have got dot with context. So this with context method is given by anyhow context function. It's just add to the error. It's like mapping extra details to the error. Failed to open path path dot display. To propagate the error early, then let mute options equal to decode options new. This provides the decoding configuration for the GIF. Then what we will do, it's not in the bracket, it should be an associated function. So this line enforces all the frames to be of RGBA format for consistent pixel handling. Then let mute decoder equal to options dot read info. So this read info is the actual method that initialize decoding file with the context. That's just passing the error format. uh, Failed to read GIF header at path dot display. Propagate the error. Let's give the canvas width equal to decoder dot width. Let canvas height equal to decoder dot height. With our method, let repeat equal to decoder The repeat is the looping behavior. If we want to play it once or infinitely, or then we declare the frames. Let's initialize the new vector. We will have a while loop equal to decode dot read next frame with context. If it can't read frame, we will give the format failed failed while reading decoding GIF frames at cross path dot display. We will propagate the error here as well. And let's rewrite the function. What here we are using let sum because this method read next frame returns an option of frame. To unwrap it, we are using sum. Let index, it will be frames dot length, width will be equal to frame dot width. Height would be frame dot height. Then we have left, frame dot left. Then top, frame dot top. Delay in centiseconds, which comes from frame dot delay. Then we have delay in milliseconds, use 64 type from delay CS. Now, since delay CS is U16 type, we are converting it to U64 as declared, multiplying that by proposal. It will be frame dot dispose. Then we got, what do we got? As transparency. It will be also coming from frame dot transparent dot is sum. From is sum, we will be getting the Boolean value if it's transparent or not. Interlaced, frame dot interlaced. All right, I realize we are not pushing it into anything. Let's push it. Where do we need to push it? We are pushing it into the frames. Frames dot push, closing the bracket. Now the frame metadata is pushed if frames dot is empty. Like even after pushing, there is no data in it. Then we will bail an error. Bail GIF contains no frame, no frames, and also the path at which path dot display. This is to check, like even after passing the data, if we are not getting any frames, then it will throw an error. We'll be getting let total duration be equal to frame dot iter dot map. What we are mapping the frame, mapping the frame. Why are we mapping? We want frame dot delay in milliseconds dot sum. This loop will return the total duration of the animation, pass on the data. Okay. GIF metadata, canvas width, canvas height. What else we are passing? We are passing frame count, which will be frames dot length, passing repeat, total duration, and frames vector, passing the frame metadata. Set. Hope that it works. Let's go into the main file. Escape. Uh, let's yank this line and okay. So after that, we are having one more function in this, which will be pub function describe repeat. Takes which will return as a string if the repeat finite 0. That means repeat once dot to string if repeat is of finite count, then it should be format. Here it will be count. Then repeat infinite. Then loop forever dot string. I realized that I haven't declared the match function, which is, oh, what are we doing here? We are matching repeat. Now let's go into the main file, and here we need to import our module first. After mod CLI, mod GIF decoder, and also we will be here. We need to use create GIF decoder, and we are importing describe repeat and inspect GIF. Why the describe repeat is not highlighted? Let's check once. Okay, I realized my mistake. Yep. So what we need to do here is let me delete it from here, and yeah, okay, dollar I. So I need to paste it here. This is the another function. Now it should be fine. Let's save it and let's head to the file. Yep, now it's working properly. Okay, so here let metadata equal to inspect GIF path. And if there's a error, then it will propagate. Okay, now let it protects the GIF path. Then CIB. Here we will mention the canvas dimensions to be X metadata dot canvas width, metadata dot canvas height. Then similarly, what else do we have? CIB, uh, frame count. Let it be. What is the frame count here? Metadata dot frame count. Similarly, CIB, a repeat. What kind of repeat it will be? Metadata data dot repeat. And what else? CIB. Total duration. That's all remains. Total duration in MS. Metadata dot total duration. And let's delete this line. It's not needed. I think let's save it. Yeah, what we have to pass here is the reference and not the mutable string. So now it should work. 264. Okay, let's head to that. Oh, okay. This should be of type string, I guess. Now that should does the job. Now let's get back. Now let's save it. So the error we had is delay CS. We cannot use that directly. So what what do is let's just remove that delay CSS line, delay centiseconds line. I think it's not needed either. So let's just delete this and see. IB here we will be using frame dot delay. And this should do. Let's save it now. We need CLI as well. Let's 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 name it as inspect, and let's save this as well. Now it should work as working fine. Let's try cargo run hyphen inspect inspect assets slash post. have the metadata of the frames. Now we need to create a frame. So for that, let's create a function called decoded frame, I guess. Let's create the structure for it first. Let's create it here. Hashtag drive debug trait pub struct uh, decoded frame. What will it have? Yeah, it will have width. Let me select those. 4J. It will have width, height, top, delay. Let me copy that. Let's go back. Let's paste it here. Yep, looks good. Also, we will, in the frame itself, we need the RGB buffer as well. Let's enter. That will be RGBA pixels, which will be a vector of unsigned integer 8-bit. Okay, that's for, sorry, that's for the structure. Let's go here. Now let's create the function for that. Let's jump. Let's create a function here. What we should name that? Pub function load frame, which will take path as an input of type path, and it will give a result of, I mean, it will give us the decoded frame as the result. Decoded frame. Enter. Okay, so now for the decoding the frame, we need this file options and the decoder itself. So what I will do, since we need to, since we need to copy this and paste, let's refactor this. Let's create another function. Let's let's create that function on the top. Let's create it here. Pub function create decoder. What it will also take path as an input, and path, and what it will give us as output, it will give us decoded options as an output, which will give us a result of type decoder of file. Also, we need to import that here, decoder. So all right, and what we will do here is, let's just select that and cut, paste. Okay, I think this is fine. And it should return the decoder, right? So we are returning this options of, so we, I think we don't need to store that in a variable. Uh, let's delete options. Yep, this should do. I think we can put this in one line as well. I mean, the formatter will put it in multiple lines by himself. Okay, that was unnecessary, but still. And from here, how we will get the decoder is let mute decoder equal to will be coming from create decoder from ampersand path as path and unwrap it, and that's it. We get the file, and then let's get back to our function. Here also we will be using decoder. Let mute decoder equal to create decoder and path, unwrap the result. Let frame be equal to decoder dot options. Okay, let decoder read next frame with context. If any error found, map it with format. Failed while decoding the frame, while decoding the GIF frame. Let's pass the path here. Path dot display. Okay, I may not have mentioned the path display is coming from the standard library, from the standard path. Uh, this has associated function as dot display, which which produces the output string as human readable format for the paths. And I guess that's the frame. I think we should get this to the next line, and then context page GIF contain no frames. So now what's the difference between with context and context? The with context function just adds this error line to the existing error. Now you will see result gives us an option of frame and not directly the option. So if the option is providing us something, then the context will not be triggered. But if the option returns us none, then the context will turn that into an error and it will give the error as GIF contain no frames. Then decoded frame will pass what were the let's just copy this. Let's paste them here. Control V, J. Delete. Here this would be frame dot width, frame dot height, then frame dot top. Also, I realized I didn't turn on the caster. Let me turn on the keycaster. Okay, it's here. That would be frame dot left. Then this would be frame dot that could be frame.delay, which might be of other type. Since it, let's convert that into U64. U64 from delay, and for the pixels buffer, so this function buffer to vec is given by the decoder himself. It returns the pixel as an buffer of vector U8. I hope that's pretty understandable. If not, we will be seeing that a little bit when we write our ASCII function. Now let's see, we have some few errors. Okay, we need to delete that, and we are not wrapping that either. Let's save it. Okay, some minor errors which we need to fix. This should be that. The decoded frame, we are getting result. Okay, we need to unwrap the result here. So it's still an option. We need to unwrap that option as well. Yeah, we need to unwrap here as well. Let's insert. Now let's save. Just make sure you unwrap all at all the right places. Let's try. Let's do cargo check. Okay, no errors. Little bit of warnings, which are just for the unused variables or functions, which we'll be using soon. Next, I need to check out the functions. Cargo run -hyphen inspect assets slash roast.gif. Right, it's building. Let's see. Yep, and it gives us the proper output. We are done with the GIF decoder. I think we can now get started with the ASCII.rs file. Let's close. Let me just close the terminal. Let's head to the ASCII file. Here, the main conversion will happen. The decoded frame that we generated in the GIF decoder will be passed in the ASCII, and here we will create our first frame uh, of ASCII characters. So let's first import the required things. Use. So what all things we would need here? We would need the image library here, image ops, and from here we will be needing self and filter type. Now what these are, what they do, I will cover them later when I write the code for the specific functions. Let's use image. What else we need from this? We need RGBA and RGBA image. What else? Use. And then we need anyhow the context and result. And that's it. Also, we will be using create GIF decoder. And from that GIF decoder, we need the decoded frames. Decoded frame. This is what we need. Derive, debug, obstruct, ASCII frame. So the width U32, height of U32 and the line which will be a vector of strings. Also, these all should be public. So let's just copy them. To copy it, let's me select those, yank it. Let's undo that. Paste it here. Okay, now we got the ASCII frame. Now let's write the function to convert that. Let's write the main function that will be converts the frame to ASCII. Frame to ASCII. We will take frame as an input, which will be of type decoded frame, and it will return a result ASCII frame. Okay, so let source image GBA image from RGBA image from raw. Okay, so what RGBA function does is it creates a image from the raw data. It takes width, height, and pixels as an input. Just let me show you. First, we let us give us the input from frame dot width. Then we have U32 from frame dot height. Here we pass the frame dot RGBA pixels. Now we might need to manipulate that. So let's just clone this to have the ownership of the pixels buffer with context. If nothing is returned, then it doesn't matches the size we expected. So that would be decoded frame does not match the RGBA size, expected RGBA size, expected RGBA size. Okay, I need to make a correction here. So given GIF might be way too larger than the terminal or the frame we expect. Like we will be having a width of 80 just to have some restriction in the size. Just let me explain a bit more about RGBA image. Like how does it looks? Let's get back to Chrome. And this is the image crate. Let me close those. Let's head to SkeleDraw. Okay, so how does an RGB image looks? So it has this, and so in an image, each pixel is represented by these four slots, which is basically the RGBA. So like each pixel is represented in that way. Let's copy them a few times. So these are each pixels, and so these are the pixels, and the RGB image would be a vector buffer of containing all those as a vector with each element represent with a vector where four elements represent a pixel. I hope you get the idea. Let's do that again. So how an image is represented? Consider this as an image which will have an pixel. So this pixel is converted to RGBA, that is four elements. So this is how an pixel is represented. Let's group them and copy them. So for example, this is how the pixels are arranged. So in image RGBA image, it is an in-memory buffer. In-memory buffer. which stores these pixels as a vector of strings. Before proceeding further, we will be needing some helper functions. So let's define the helper functions first. Pixel mapper, like to map the ASCII character according to the brightness. And similarly, we would need to identify the brightness of the pixel. So let's create functions for them as well. Pixel brightness. Let's first define the brightness of the pixel. Pixel brightness, which will be of type pixel, which will take input as an pixel, which will be of type RGBA of UA type, which will return and an unsigned integer of type U8. Now let's destructure the pixel into red, RGB red, green, blue, which comes from pixel dot zero. You might be considering why pixel dot zero, because the pixel is a tuple of it looks like. So this is how it look. So pixel dot zero, the RGBA vector. Here also we have the alpha. Alpha is the opacity. Also, if alpha is zero, now if the alpha is zero, then we treat it as a white pixel, completely white pixel. Then let brightness, for brightness, for brightness, we will be using the luminescence formula, the standard formula for it. Let me show you. We will be using this formula. This is according to the human perception. You can read more about it by searching this exact statement. Standard luminescence formula. It was 0.299 multiplied by red plus 0.587 into green, 0.114 into blue. So the red, blue, green are of UA type. So let's convert them into float. That will be F32 from, okay, and let's do them here as well. F32 from green, F32 from. Then we return the brightness as brightness dot round. Let's round it up and as U8. So that is how we define the brightness of a pixel. And according to that number, uh, we we need to define our uh, character set as well. For the ASCII characters, we can use lots of, but I decided to keep it limited. So let's create that constant as well. That will be const ASCII char set. It will be of type U8. It will be of byte type. So let's define byte, and it will have, this will be the peak brightness, then little lower, then we have percentage multiplied plus minus space or dot space. So this is the character set we will be using. Now we write the function for brightness to ASCII, brightness to ASCII, which will take a pixel as an input. It will be of type and RGBA of U8, and it will return a character. So let brightness equal to pixel brightness of pixel and pixel. Okay, here and is not required. Ampersand is not required there. Let max index ASCII cursor dot length -1 index use size from brightness into max index divide by 255. This would just normalize to which one to select from among these, and then we just return the index sky character set set index as char. Also, we need one more function that would be resize to terminal. I mean, when you convert the GIFs pixel by pixel, it sometimes it way too larger for the terminal to handle character by character. So to fit them inside the terminal, we will be converting them to the size that could be that fits into the terminal. It will take image RGBA image and width as an input, not any width, the max width, which will be of type U32, and it will return a RGB image. I hope you have the clear idea of RGB image. I have already explained that, which is right here. And now here we will be manipulating it with max a little bit. Let source width image dot width dot max. This is just to avoid storing 0 as a source dot height GHT height. No. Let target width equal to source width min max width dot max one. This is to clamp the width. For example, so let's head to ASCII draw. For example, this is our terminal. If in case our image has a width which is greater than the terminal, then this statement will select the max width which is provided manually by us. Or if the image width is smaller than the terminal, then it will choose the source width itself. And if both are 0, then it will select 1 so that it doesn't store at a 0. So none of the height width would be 0. Let aspect ratio source height as f32 divided by source width as f32. So this is the aspect ratio of the original image, I mean the frame. And then we will convert it into as per our requirement. Let target height equal to target width into aspect ratio into half. Now this half we are using since in the terminal generally the height of the characters are much more than the width of the character. So to balance that out, we are using half over here. U32. We need to round it up as well. Round just in case if it's 0. Let's wrap this up. Dot max 1. Just in case if it turns out to be 0, it will be still 1. This max 1 is just for the safety measures. The actual image resizing will be done here, and now the actual resizing will be done by the image ops resize function. Which image to be resized? Target width, target height, of height and the filter type which will be triangle. I will explain what is that as well. Filter type triangle is basically the resizing algorithm. Is also called as the bilinear interpolation. What is does it considers the nearby pixels and fill in the pixels. The filter triangle is a resizing filter. So it is a resizing filter which smoothly bends the nearby pixels to avoid the blocky output. Now let's first resize the terminal equal to resize to terminal, sending the source image. Then we need to send the target height and we are keeping the max width as 80. Like that's, I mean, you can play around the numbers and try to see what fits your terminal the best. Let lines resized dot rows dot map. We map the row dot map. Inside the row we map the pixel brightness to ASCII pixel. Collect, we collect it as string. Let's mention that string. Let We are going in each row, converting each pixel into an ASCII character and collecting that as a string, and that string is collected into the vector called line. And now we just have to return the result. Okay, it will be of type ASCII frame, where width will be resized dot width, comma height would be resized dot height, comma lines. For lines, we are just passing the lines. Let renaming it as line as well. Head to the main, and we need to use it here as well. Let's import it first. Mod ASCII. Then we need to import it here as well. Use create ASCII. We will be using ASCII to frame. I mean frame to ASCII. My bad. Also from the decoder, we are importing many more things. Like inspect GIF would be the one, and also load frame. What else to in the command play here? Let frame equal to load frame. All right. So let's see what we need to do here. Let frame equal to load frame from GIF path. We GIF path. We got the decoded frame. Now let's pass the decoded frame to build the ASCII. Let ASCII frame equal to frame to ASCII. We pass the frame and frame, and let's unwrap the frame. The code lens is actually very helpful. Okay, now we need to print that as well. Let's print the ASCII frame, printing the ASCII frame size. Let's loop in for line in lines ASCII frame dot lines. Uh, println, print the line, and that's it. Do the job, and then return OK. That's not needed. And let's hope that it works. Let's save it. Do we have any errors? Okay, we are getting few errors. Mismatched type reference. It should be and, not here. Here it should be and. Let's save it. Okay, so we have quite a lot of errors. Okay, so we have an error basically which says the image buffer is private field, so we cannot access that. Okay, so we have to return here the with as of method. Now, then those should be public. I think now that should work. Okay, we still have cannot multiply target with must be as a U32. Let's consider that as float F32. Now it should be possible. Okay, now we still have an error. Image buffer. We haven't unwrapped here. Let's unwrap the buffer. Yep. Please take care of these little things to unwrap the result. I hadn't unwrapped here, so those bugs are fixed. Everything will be shared in the, I mean, as a GitHub repository as well. So you can refer the code to check your code is correct or not. From there, it's as well. So now I think we have fixed all the errors. Let's head back to main. This looks fine as well. Let's try it in the terminal. Cargo check. Yep, the functions should run as well. Let's first check cargo run. Inspect, inspect assets slash ghost.gif. Yep, it works. Now let's try the command play if it prints the ASCII character or not. Okay, and here you can see fine, it converted the ghost GIF as an ASCII character set, which had a frame size of 80 by 40. It looks pretty nice. I think we don't need these things, the ASCII frame or width. What we actually need here is the delay. So what we need here is the frame dot delay. This is what we need actually here. Also, let's change this struct. Let's delete that, delete this as well. And then we need here pub delay mess, which will be of type U64. Or let's just change it first. Okay, here we don't have the width and height. Just delete the statement. And now no more errors. Let's just check once more. Cargo run play and it's still working pretty fine. Yep. Let's close the terminal. Let's see how to render in the terminal. For this, we will be using the Crossterm library, OpenXCali draw, and also Crossterm. So Crossterm basically handles the clearing the terminal and manipulating the cursor on the terminal. You can read about it. Let's head to the file, put the bunch of libraries we will be using first. Use standard IO, the standard input output library, the standard output write trait. We will be also needing the thread time duration. I will explain the function of each of this when we use them in the function app itself. For now, let's just anyhow. From anyhow, we will be using bail result context. Let's use cross term from the cursor. We will be using hide, move to, and a show. These are some cursor manipulation commands, and use cross term execute. This execute runs these commands in the terminal. Then we have use cross term terminal. From that, we will be using clear and clear type. So the clear functions clears the whole terminal, and clear type specifies what we want to clear, like for a line or the whole terminal or just few words and sort of things. And also we will be using GIF repeat. This is for repetition of the GIF. Now our custom creates, use create ASCII frame, and then we name our function pub function play animation frames, and also repeat how many times it would repeat, which comes from the GIF trade GIF, and we will return a result. So the very first thing we will be checking is if frames dot is empty, then bail ASCII frame not found, then let mute std out is equals to std out. It gives us a writable handle which can be manipulated via code. Then we execute our commands. We execute this and we hide the cursor. So when we execute our commands, like this to display the GIF, we hide the cursor. That's what this statement enables. Let play result. Let's name it as play once. We need to define this function. Here we will be passing the mutable reference of std output, and then we will be passing the frames and also the repeat. Now let's also define mission play once. Okay, let's define that play once function. It will be play once, which will take std as an output, which is a mutable write rate. Frames would be of ASCII frames, and then repeat will be of type repeat, and it returns when this results result and an empty tuple. This is the documentation. So basically, write is a trait which is used to write bytes and to flush out the output at once, like without any buffer. Match repeat. Repeat is of type finite 0. Finite 0 means play only once. Okay, so I made a mistake. Okay, since we are already playing once, we don't need the repeat actually. So let's just delete that. Okay, so we don't need that. Now let's define the play once function. So in the play once function, we don't need the repeat because we are actually playing it once only. Let's select it, delete, and we delete this as well. Let's loop for frame in frames, execute what we need to execute, standard output, what we have, then move to location 0, comma 0. That is the top left corner of the terminal. And then clear type. Clear type will be all. And if any errors, then for line in ASCII in frame. Now we are using nested loop, frame dot lines, print ln, yeah, print the line. Also, if any error, let's propagate that. Here we do std out dot flush. The terminal executes this loop line by line, right? Like it prints line by line. The flush method force the terminal to print the whole ASCII frame at once rather than line by line, adding a buffer line by line, just to print the whole ASCII image at once. After flushing out the output, then we will use time sleep duration from millis. It just means duration in milliseconds. Frame dot delay slash ms, and then we return the okay empty result. Also, we need to ensure that the frame delay milliseconds should never be 0, because if it's 0, the animation will end in an instant. It will be like just screen flashing, and so to ensure that it's not 0, we create a function. Let's create a function. Ensure delay, which will take delay mess of type u64 as an input, and will return an u64 as output. If delay ms is equal to 0, then we return 100 as an 100 milliseconds of delay. We are adding that manually. Else, if it's not 0, then pass whatever the delay ms was passing. And let's use this function over here as well. Ensure delay with this input. And yep, let's save this. Now it should. Okay, so here we have a result. And if we find any, I get any error, let's propagate that. And now let's print that on the. Also, we need to restore the frame. Let's restore result. Let's put it out. Move to 0, comma 0. And before that, just show the cursor. Show. Also, this won't be called automatically. Let's execute that. Execute, and then we just execute play result. We don't need to wrap that here as well. In these few steps, there are many things that can fail. For example, the standard output can be failed. So we need to return that error. So we are returning as the result anyhow create. So we don't have to manually write the errors for them. That's why we are using the anyhow. Till now, we were just rendering a single frame, but now we need to render the whole GIF. So for that, let's open the decoder again. And we need to make some changes in the decoder. And let's close the Explorer. So here we need to make some changes. Case the empty format that is not required. So let's just delete that. I think let's delete this. That bracket is not needed either. So first we done for the frame. Now we will be doing that for the GIF. So let's create a structure. Let's derive the debug trait. You might be wondering, if we are not using pretty format, then why are we using the debug trait in the first place? Now, I have plans to expand this project in various ways. And so for debugging the structs, it it will be required for debugging. So that's why we use the debug trait. Because as the project expand, we might need to check what struct we have already created, and if you want to contribute to it, it will be helpful to you as well. That's why we are using the debug trait, even though we are not using the prettier format as of now. Let's create a struct decoded GIF, and it will have only two fields, pub metadata, which will be of type GIF metadata. Then we will have pub frames. Frames will be a vector of decoded frames. So we are not using the top and left in the frame itself, because it will be covered in the whole canvas. So we don't need those two. So let's just delete them and delete the top as well. Before we were loading the frame, and actually now we don't need to load the frame. We need to load the whole GIF. So for that, we will be writing something similar. Let's write the pub function, load GIF, which will take path as an input, which will be of type path, and it will give result of type decoded GIF, decoded GIF, where we again create the mutable decoder equal to create decoder using path and unwrap it. Let canvas width be equal to, we are using usize. I will let you know why we are using usize. From uh, from decoder dot width, and similarly, let's just copy this and paste it. Okay, let's delete this as well, this as well. This is a neovim function, not related anything to Rust. This is used for replacing the file. Now you see the width is changed to height. That's why neovim is cool. You should also use it. Let repeat be equal to decoder dot repeat. Now let's initialize the canvas. We are initializing a vector of 0 of length, canvas width into canvas into 4. Why 4? For RGBA. So this is the dimension of the canvas. Now let us initialize the vectors for metadata of frames equal to vec new, let mute decoded frames equal to vec new. Okay, now we will be looping on to the frames again while writing while let some frame equal to decoder dot read next frame with context format failed decoding GIF frames at path.display, and if any error, propagate it. Let delay mass equal to u64 from frame dot delay into 10. 10 for converting the centiseconds. The frame dot delay return as a centiseconds time, so we are multiplying it by 10 to convert into milliseconds. Then we will be drawing the frames. We will be creating a function called draw frames. So let's create that function now. Should I create the new file for helper functions, or maybe I can refactor it later? But for now, let's keep it here. Function draw frames. Okay, now we will be writing some function similar to load frame. We will be writing now for public function load GIF, which will take path as an input and path. And as a result, it will be giving us decoded GIF, result of type decoded GIF. Enter. Now let mute decoder equal to create decoder path, and let's unwrap the result. Then we will be creating let canvas width equal to decoder dot width. Then we will be having, okay, now let's just copy it, paste it. Now I will be using some vim commands. This is only for replacing the width as height in the line. That was the new vim command, nothing related to Rust. So I'm not explaining that. That's why, but new vim is cool. You should also use that. Height, let repeat, not capital one, let repeat equal to decoder dot repeat, let canvas buffer. This is the canvas buffer, which will be a vector initialized as 0 of length, canvas height into canvas width into 4. Now why 4? Because there will be RGB for each pixel. So that's why height into width into 4. That is the image buffer, how canvas buffer would look like. And then we have, let's also initialize the metadata frames. Metadata frames equal to new vector. And let's copy this. Let's paste that. Let's d. Let's change it to decoded frames. Okay. Oh, yeah. Okay. So Rust wants when you are initializing an array, it expects it as usize. So let's make it usize. Size from canvas height, and let's do the same for canvas width as well. From now, let's create the loop to render the frames, just like we did before. While let some frame equal to decoder dot read next frame dot with context. If it fails to read the format, failed to read GIF frames at author.display and unwrap this. Now we got the frame, and what we will be doing with that frame is, now we have the frame. Now we will be drawing the frame. First of all, let's extract the delay. Delay millisecond is equals to u64 from frame dot delay. Remember, it returns us into centiseconds. Let's convert it into milliseconds. That's why we multiply by 10. And then we will be drawing the frames. Let's create a function draw frames. And here, okay, so now let's write the draw function. So for the draw function, let me just go to the insert mode first. So function draw frames. We will take canvas as input, which will be of type mutable reference of U8 array. Then we will be required with canvas width of type U16. I think that's it was U16. Canvas height, which is also U16, and the frames, which will be of type will be of type frame coming from GIF. And let's mention the lifetime as well. This is how you define the GIF, I mean frame. So now to understand the draw frame, I think we need to understand the frame will be rendered in the terminal. So let's go to Xcali draw. Blue box is the terminal, and the white box is the canvas where our GIF, ASCII GIF will be rendered. So for example, if this is the character, so how do we find the location of the character? The first of all, we have the offset both in X and Y, where we want our rendering. This is defined by the X and Y offset, where our frame would be actually, and the coordinates of the character would be calculated by Y offset plus frame Y, like how many units from the Y axis and how many units from the X axis. So let's code this out. I think it's pretty easy to understand by looking at it. I gave the diagram for easy, I mean, for visual understanding. Let's code that out. This GIF would be of reference type, the frame reference. Let's declare some variables which will be required here. First of all, would be the frame width, which will be of usize type. From it will come from the frame itself, frame dot width. That's it. Let's copy this by timeline, and then I will replace it. I have just pulled it down there. All right, let's continue with V. And here instead of height, we will be, I think we don't need these two variables. So let's delete this. I think this will be enough for Y in 0 dot dot frame height for X in range frame width, what we mentioned in the, like, so here let destination X is equals to frame X plus X, And here the frame X is in the X we have left. And similarly, let's copy this, paste it here. This will be Y, frame top plus Y. Also, let's add the condition. If string X is greater or equal to use size from canvas width, or the string X is greater than equal to use size from canvas height. Continue. Basically, if the pixel lies outside of the canvas, then don't print it, just let the loop continue. The source index equal to into frame width plus X into 4, the index of the pixel in the buffer. If you remember, let me show you. H, yeah, if you remember, so many such pixels lies, and each pixels is represented as an byte array of RGBA value, and each pixel represent that. So we have this buffer. This is the buffer. We traverse the buffer using this formula. We multiply the frame width into Y plus X multiplied by 4. I think it's pretty understandable if you think a little about it. And if not, I will add something in the notes for that as well. If you still don't understand about that, it might be a little tricky for visualizing, but once you think about it, it's pretty understandable. The destination index, where the character lies, which will be equal to destin Y into canvas width plus destin X. Then we have alpha. Alpha is basically the transparency of the pixel buffer. Frame dot buffer src index plus 3. I hope that's understandable as well. Since here we are iterating over the alpha only, so we are skipping the 3 RGB and heading traversing only the alphas here. That's why plus 3. Also, if alpha is equals to 0, that is the pixel is not visible, then continue. That's till destination index plus 4 dot copy from slice and frame buffer src index to src index plus 4. So here we are copying the frame onto the canvas according to our width and height of the canvas. Pass on the function here as well. Here the canvas can be passed as the canvas itself. Then we pass canvas width. Then we pass canvas height. And then we pass the frame. Also, I realize it's mentioned frames here. It should be frame because we are taking single frame here. Also, we need to mention here it is the mutable reference metadata frames dot push. We are pressing frame metadata. Now we need to pass the index, that will be frames dot length. We have, okay, not frame, so we can copy these from the metadata itself. Exit. Let's copy all this. So we I think we need everything from here, so let's copy these. I have copied those, and let me paste it over here. Let's Close this. And now also let's push the decoded frame. Decoded frames dot push. What we will be pushing here, decoded frames. There will be width. I think we can, all right, just like write it down, canvas width. Then we have height of type canvas height. Then we have delay, which will be passed as on. Then we got RGBA pixels. So let's clone the canvas here. Canvas dot clone. And after drawing a single frame on the canvas, how we will be cleaning the screen, we need a function for that as well. Let's call it as apply disposal method. And okay, let's define that as well. Let's write function apply disposal method. So I will just copy those here itself. And yeah, this should do. It returns nothing as well. So now let's write the disposable method. The light is flickering. I mean, sorry for that. I am not having an actual setup. I mean, lightning system or something like that. Frame dot dispose method. If the disposal method background, then we clean the background. So clear canvas. We will create this function, and this function will take the same outputs. So let me just paste it over here as it is. Uh, Now clear canvas function, let's create that as well. Function clear canvas. It will also take the same inputs. So let me write it X, and okay, what it clear canvas would do. Now, just like the draw canvas, we will be just clearing the canvas here. So let's copy everything. Let's copy everything and paste it right here. Okay, everything looks good. And here, instead of frame buffer, uh, CIB. Okay, let's stay here. CIB. Here we will initialize as 0, 0, 0, 0. And that's how we clean the buffer. I mean, clear the canvas, setting the transparency as 0. This should work. Also here we don't need to check the alpha. So let's delete that. Here we don't need the source index as well. Let's delete that. Here we just need to put clear the canvas completely, and that should work. Let's pass the arguments over here as well. What we want to pass here. Yep, we want to pass these things. Let's copy these. Let's copy this, and we don't need to pass here as mutable since it's already mutable reference. I think everything should work now. So the first error, I guess, we are not returning the decoding GIF yet. So I think let's complete the function first, and then we can look into the errors. Metadata frames is empty. If the metadata frames is empty, we throw an error. GIF contains no frames at path dot display. We calculate the total duration of the frames, just like we did before. Here is that. Let me just copy this and we paste it over here as well. Let's paste that. Let's copy this as well. And here we paste that. And we are not sending that as metadata equal to GIF metadata. Metadata frames outline total duration and should be metadata frames. And now let's return what we actually need to return here. That will be decoded GIF. Enter. We will pass the metadata and the frames. Frames will be equal to decoded frames. Now let's save it. Okay, we have still lots of errors. The very first thing, okay, unwrap is not required here. Let's clear that. Save it. Okay, I think we don't need to unwrap here. Let's save. Yeah. Cannot find frames in that. Okay, this should be metadata frames. Metadata. Now this should be fine, I guess. Okay, we fixed few of the errors. Now we have, what other errors do we have? It's not metadata, it's metadata. It should be metadata frames. I think now it's fine. Okay, we get rid of some errors here as well. It should be metadata. Save. Okay, let's make them mutable. This should be mutable as well. Save. Okay, we still have few errors. Let's deal with them as well. No method found in the K. We are not getting the correct reference here. Here are the errors. We don't need this. I think here as well. We don't need this. We know this. That. Now let's save. Skip. We still have few errors. Cannot multiply usize. Let's convert that as usize. This should work. Here as well, usize. Save. And yeah, we fixed all the errors, hopefully. Hopefully it should work. Now this fixing error might be a little bit confusing. You just need to check the reference, where are the parameters and the arguments are coming from. And if you need any reference for that, you can check out my GitHub, which will be mentioned in the description of the YouTube video. So you can check from there if you have still any confusion left. All right. Now let's get to the main function. I think we should keep this and let's rename this as frame. We will be having a subcommand frame which will print the frame. So let's add that in the CLI as well. So here we have the commands. Let's have the frame command, which will take GIF path, as before, type path buffer, and yep, we added another subcommand frame. Let's save this as well. So here we saved one more command, and in the main function does the same thing. Right, let's now create the play command, play GIF path, and if we found that, then let decoded GIF equal to load GIF, not fig GIF, and GIF path, unwrap it, and what else? Let ASCII frames equal to decoded frames, decoded GIF dot iter. Okay, we need to iterate over the frames of GIF decoded iter, and then map them frame to ASCII. It will automatically take the input which we are getting in the map and pass on to the frame to ASCII function, then collect the result and close it. It will be of type result, result of vector empty type. Also, we need to put an arrow bracket here as well. Put arrow bracket here. Yeah, now I think it's fine. Render the animation. So play animation. Actually, I forgot the name. What was the name? Let's check out in the terminal. Let's Okay, the terminal has play animation function. We need to play animation. It's not okay. We haven't imported the terminal module. Let's import that. And let's use create terminal uh, play animation, and which will take the ASCII frames and the repeat, which comes from GIF metadata dot repeat. Also, if any error, then pass them on, and a comma over here. I think now it should work. Okay, we got errors. Let's see what errors do we have. Let us check what the okay, we had many errors in the terminal as well. I hadn't checked the terminal or what. I think we need to first fix the error here. Let's remove cross term Failed to reserve. Let me check the cargo, not lock, cargo terminal. Okay, we hadn't installed Crossterm. Let's install that. Cargo add Crossterm. Yeah, now it has Crossterm. Now let's check, head over to the terminal file and okay, still have bunch of errors here. Was this file incomplete? Okay, we have play animation. Let's close the terminal first and let's close the Explorer as well. Okay, let's read into the error and let's try to fix that. The very result enum. Okay, we are not play result. Play once. Okay, I realized I have half completed this result only. Let me finish this. Restore result to save the previous state of the terminal, how it was before playing the GIF. So execute standard output, show, move to. So before rendering the ASCII GIF, just show the cursor and move the cursor to the top left of the terminal. And if any errors here, then return that error, or should we return it over here? Restore result and we return the play result. ASCII frame doesn't have any is empty function. Yeah, because frames is not a single ASCII frame, it's a vector. We are passing an array of frames. This is where I made the mistake. Please refer the GitHub so you don't make such mistake like me. Expected ASCII frame found. Okay, I think here also we are passing the frames. It is an array of frames. Let's fix it here as well. And after that, it is this. Okay. Yeah, here we don't need that. Let's save. Okay, most of the errors are gone. Expected a type, found a trait. We are using a right from this. We expected a type, found a trait because we need to implement the trait. Now this should work. Okay, frame dot lines. Okay, cannot move, which is behind a shared reference. It's a shared reference. So let's give it as a reference. Okay, we fixed all the errors. Okay, mismatch type. Okay, so GIF path is of type and path. Okay, here we need to pass it as path. That should do. Expected repeat and found a string. Think let's that should do. We need to make changes to the CLI as well. Let's head over to the CLI. Okay, here is the mistake. This should be path. Let's save this. Minute spelling mistakes. Let's save this. What are we? Let me close few of the lines. Let me close this as well. Close the GIF decoder. Close this. Okay, so the CLI has an error and main has an error. Let me open the terminal, and we have an error over here. We are passing repeat of type repeat. I think for now it doesn't matter because we are playing only once. Let's For now, I guess it's okay to remove this repeat. Let's delete this. Let's save it. Yes. And let's head to main. Let's not pass the repeat. Okay, let's try. Let's see if our code is working. We fixed lots of error, around like 15 to 20 errors. Now let's check first of all insert mode cargo check. We have lots of unused variable, they say, uh, but that's okay, I guess. And let's try cargo run frame assets ghost dot gif. Okay, let's see. Hopefully, okay, it prints the frame as it should. The frame sub command is working fine. Now let's try. Cargo play. Hopefully, let's see if the animation works or not. Holy shit, it works fine. Uh, so it for now it plays once because we that's how we mentioned the function. Let me open a new terminal so that I can show you. For now, let's close, uh, quit all, and let's run car. We already have wrote the command. Let's play. And the GIF works fantastic, absolutely fantastic. So I guess that's it for the first part. Uh, Now, the expansion of this project could be that the frames we are getting somehow to render in the NeoVim dashboard. How cool that will be if we can do a GIF rendering in our NeoVim dashboard. That's one of the expansion I am thinking of. And what other use case you can think of, feel free to comment below. If you have any questions or doubt, if you didn't understand any of my explanation, feel free to ask me out, reach me out. All the handles are mentioned in the description. Thank you for watching. Make sure you like, share, and subscribe. This would be a great learning project. And I think every developer should start making content right now because that's one of the best ways to learn. You really deep dive when you want to explain this to think someone else. Let's do git net, git add all, git branch master node will be main. And then let's copy this as well. Let's add the remote origin and then git push origin main. Yeah, how can I push something to main when I haven't committed anything? Git commit message. Let's put it as feed CLI with the inspect. print and play command. Wow. Yep. Now it's uploaded. Now let's try pushing to origin main. And now it should be done. Now let's check if it's fresh. Now it's uploaded. I will add a detailed README file as well and maybe write a blog on it as well. If you find this project helpful, make sure to give it a star and try to make on your own. Feel free to contribute to this as well. Thanks for watching. Bye for now.